talked yet, but I'm assuming I can hear all of you. But yeah. All right. Good morning, everyone. Today is Monday, November the 22nd. We are starting our final review today. Just to start off to share with all of you. So this is a picture of me and my dad from 2019 October, and this month a year ago, I lost my dad due to complications to pancreatic cancer. Um, I'll be taking off next next Tuesday, the 30th. I'll be taking that day off because of him and hanging out with my mom. But yeah, I just thought I'd share it with you. It was a year ago today. It's my best friend. But anyway, so you guys were sent an email on Friday, and I gave all of you the review. Hopefully, you check your email. And your job was to complete the first 5 problems of this review. That was your job. And in the review, you were given the section to find this information. So this would kind of steer you in the right direction in terms of where to revisit and look this up. Because for guys, your final is worth a lot of points. If you have an A in this class and you don't get an A on the final, you probably won't have an A in the class anymore. Same thing for a B. If you have a B in the class and you don't get a B on the final, there's a good chance you may not have a B in the class anymore. It's worth that many points. So make sure you take that consideration before you take the final. Make sure you are ready and you know how to do every single problem in this review, because any email that I receive about that, I didn't get the grade I wanted, this happened, I don't know, I might send you like a shrug face emoji. I don't know what to tell you other than you should have prepared better. And if you wanted a certain grade, 2 things should have happened. You should have already had that grade going into the final, and 2, you should have at least got that same grade on the final to keep that grade. So every year, this is my 9th year teaching. Every year I get students that either come to me in person if I taught in person, or online and send me an email, and they talk about how for whatever reason they really need a B in the class, or they really need to pass, or really need a C. However, the entire semester you haven't had that grade, or you haven't been passing. And you can't have these unrealistic expectations of earning an A in this class or a B in this class if you haven't had that grade the entire semester. Okay. And also, if you don't prepare for this final and you don't do well on it, in my eyes, you probably don't deserve that grade, because you couldn't prove that you could get that same, you could earn that grade. Everything from this review that I have, you're going to see a problem just like it. So if you can do this review, you can do the final just fine. Just like every test that you've had in this class, the review that we've done in class has been pretty similar in the types of problems, if not identical, the types of problems that you get on the actual test. So hopefully there's no surprises. Yeah, it's fine. I can't enforce whether you use your notes or not. I'm going to assume a lot of you probably use your notes on the test. It's out of my control, but that's fine. I just make sure you're prepared for this test. Your test is 25 questions. Combination of multiple choice, select all that apply, fill in the blank. Just everything you've seen on your past tests. All right. So, all that said, how many of you were able to do the first 5 questions on this review this weekend? I totally understand if you have a full-time job during the weekend and you were unable to get to it. I get it. Or maybe you just didn't see an email from me. I get it. But you only had 5 questions. So it looks like, I don't know, looks like half of you were that are here right now, which is there's 8 of you here right now, but half of you were able to get the first 5, or almost the first 5 done, and maybe 3 of you looks like either didn't see my email, couldn't get to it working or whatnot, or had something going on, and I get it. So yeah, so we're gonna go through it, and guys, it's it's more beneficial for you to go to these sections and try to figure out how to do these and read about it. You will get more out of it. It's um, than me just showing you how to do it. You trying to figure it out and you working them out and getting the right answer. It's has more value than me just showing you the answer. It really does. All right, so let's look at this one. Graph the inequality. So this is from Unit 1, Day 2. So this is like probably our second lesson of the semester. So we want to graph the inequality. All right, let's see how we do this. Um, Now, the first thing that we need to do, whoops, that was one big box. It wasn't. We want to divide everything by negative 15. And when you divide by negative, what happens? Yeah, we flip the sign because we divided by a negative. So that's the first thing. Yeah, don't forget that little piece. Okay, now the next piece. Did anybody discover what we need to do when they reviewed this material? So we do need a square root, but there's something else that we need to do. So remember, this number line is that we need a graph on is it's real numbers. We only care about the real numbers. So looking at the square root, what can we never have under a radical if we want to keep our solutions real? Yeah, we can't have this stuff under the radical. We can't have this stuff be a negative. So if you reviewed the module, you would have discovered that you would have to have taken what they call that, the radicand, and we want to make it greater than or equal to 0 to have real solutions. So this piece needs to be greater than or equal to 0 for real solutions. So we had to kind of split this problem up at this point. We have this part of the problem, and then we're going to continue this part of the problem. Look familiar. When I reviewed this final on Friday, I was like, yeah, I don't remember doing that, but I think we must have, right? All right, and then so this part here, we're just gonna let's go ahead and solve this one. This we're gonna add 2 to both sides, then divide by 4, and we're gonna have this piece done. All right, so that part of it is done. X needs to be greater than or equal to 1/2. So that's the first part. All right, or the second part, or however you look at it. Let's continue this. We're gonna square root both sides. I'm sorry, not square root. Square both sides. Pardon me. Square both sides, get rid of the radical, and squaring the 4, you get the 16, and then obviously squaring the radical makes it go away. From here, we're going to add 2 to both sides, and then we're going to divide by 4. So now we have both pieces. X needs to be less than 9/2, and X needs to be greater than or equal to 1/2. So there's the 2 pieces. Over here, we're gonna write these constraints as one inequality statement. All right, so X needs to be greater than this number, but less than this. So what number is going to go in this box right here? Yeah, it's the 1/2. It's because, well, remember, X is between these 2 numbers. So X needs to be greater than or equal to this number, and then less than or equal to, or in this case, well, just less than that number. So we're just writing this as one inequality statement. And all of you in this class should be able to take these separate ones and combine it into one. This is a skill or concept that you've all should have learned either in grade school or at least your freshman year at the latest. But yeah, and guys, remember, we always read from the variable to the number. So no matter where this variable is, like here it's in the middle, here it's on the left in both of them, we always read from the variable. So X is greater than or equal to 1/2. Does that match over here? X is greater than or equal to 1/2. Yes, it reads the same. And X is less than 9/2. X is less than 9/2. So it reads the same. And then below that, I'm just going to write it in decimal form because it's easier to graph points when it's written as a decimal versus a fraction. But your answer, if they wanted you to type it in, you would type the fraction form. We never want to have decimals as answers unless otherwise stated, or the problem already had decimals to begin with, or it's money, right? All right. So then we plot these points. And at the 0.5, is that going to be a hollow or a solid point? And how do we know? So we're kind of split, looks like. How do we know if it's hollow or solid? The greater than or equal. Yeah. So this is a x is greater than or equal to zero point 0.5. This symbol tells us what? What does this tell us? Hollow or solid? It is definitely solid. Yeah. Remember, if it's when it's also equal to, it's a solid point. That's why when you plot points on a graph, they're always solid points, but it's because those are always equal to points. The only time it's hollow is when it's not also equal to, like in this case, 4.5. X is less than 4.5. So it's less than, but doesn't include it. That's why this point at 4.5 is going to be hollow. Hopefully that makes sense. And yeah. And then because of these constraints that we wrote as one, it's definitely connecting. But we could also do test points just as an extra check. We would check a point to the left, in between, and after. We should get a false if we plug in 0 into the original problem, we should get a false statement. If we plugged in like a 1, 2, or 3, or a 4, we should get a true statement. And if we plugged in a 5, we should get a false statement. So on your test, hopefully all of you do some extra checks just to verify that we are actually connecting them and not diverging outwards. I hate for all of you to assume they connect when they don't on your test, because it could be either one based on really the math. Be careful. Spend the extra time. Do your test. Your test points. All right. Next. Or any questions before we go on to the next one? All right. Number 2. Remember partial fractions? We want to write this as a rational expression of two, rational terms. Yeah, decomposition or decomposing. All right. So, what do we have to do first when doing this problem here? Let's pretend we didn't see that part. Yeah, we need to factor the denominator. Definitely. So hopefully all of you are able to factor your denominator. Two numbers that add to -10 multiplied to 16. That should not be an issue. So you want to factor first. All right. So then once we have it factored, we're going to set it equal to a over your first factor plus b over the second factor. And depending on the order of your factors, depending on the order, these may be switched. You may have b over this first one, a over the second, and that's okay. You know, if all of you did your examples um, during unit one, you would have, people have asked that, and I've answered that already. But next, we want to, we're going to solve for a and solve for b. So we want to first, we want to clear fractions by multiplying everything by, these two factors. So that is the second step. Multiply the left side by those factors and the right side by those factors. Doing so, it's going to clear the fractions on the left. And on the right, we distribute these to both terms. And when you distribute this to your a term and both of these to your b term, these are going to cancel out, and you're going to have just a times x minus 2 for your first one. And then for your next one, the x minus 2's cancel out, and you're just going to have b times x minus 8 for your. Again, guys, if one example on the review is not enough, you need to go to this section and work out some example problems from this. Remember, this is a review. This is not me teaching everything start to finish. That would just take way too long. All right, next, getting closer. We now need, to solve for a and b. So the way that I do these problems, the way the module do these problems, a little different. The way I decide a and b is I look at this and say, all right, what will make this a go away? And it'll make a goes away when x is 0. Or sorry, not x is 0. When x is 2, because 2 minus 2 is 0. And then what will make this b go away? Well, it's when x equals 8, because 8 minus 8 is 0. So based on what I see here, those are the two values, the two just arbitrary, random, not really random because there's a reason why we choose them, but we want to solve when x is 2 and when x is 8. This is all kind of coming back, and then we're just going to plug in 2 into the equation above there, and then we just solve. We can see how we get a to cancel out. That's the whole point. And then we're going to solve for b. So now we got b is 1 over 6. And then we do the same thing for when x equals 8. We plug it in, and the whole point is to make, the b go away. And then we're going to divide by 6, and then that's how we get the a value. So for your final answer, all we're going to do is we take our a and b, and we're going to plug it into right here. We're going to plug in, 11 over 6 for a and 1 over 6 for b. And when you plug them in, just like in the past that all of you have already practiced many times, when you have, for example, 11 over 6, you can't have a fraction in the numerator within a fraction. So 11 over 6 is the same thing when you put it in the numerator versus putting it, like this, 11 over 6. And again, if you are confused of how I got this answer from this, you need to go here and review it because you've had many examples where you did that. None of this should be new. You just might be a little rusty. Simplify it. You mean like expand it? Or not expand it, like distribute the 6 and the 8? Or not 6 and the 8, the 6s. I don't know, I keep saying 8. 6 here, distribute, and then distribute. Because they want us to decompose. So I guess fully factored is what they want. Yeah, if you were to Like if you were to distribute, or I don't know, were you thinking of making these like common denominators and then combining them into one fraction? Is that what you're thinking? Oh, just distribute the 6 on both fractions? Yeah. Yeah, we just don't. They want it fully factored. I think on your final, you're gonna have like fill in the blank. It wants you to put in like the numerator value and the denominator value, and it's probably or it might even have these factors already filled in. Just like your test. If you think about this question on the test, I think that's how they had you do it. They had just fill in the blank boxes, and they had it partially done. Yeah. All right. So that was number 2. Let's go number 3. How many roots does this polynomial equation have? All right. Give me give me how many stars. So choose the number of stars that represent the number of roots this polynomial equation have. Have or has? I don't know. All right, we got 8 people here, and only 2 of you responded. Uh-oh. Oh. Oh boy. Good thing we're reviewing. Only 2 of you got it right. Only 2 of you got it right. Sabrina, you got it right. And Noah, you got it right. So those 2 people that got it right, can you tell us how you know what the answer is? Yeah, you just count the exponents. So we have 2 plus 2 plus 1 is 5. So how many roots does this polynomial have? Well, it has 5. This is a freebie, in my opinion. It has 5. Yeah, it's the multiplicity. You were correct, Noah. Also called the multiplicity. Oh yeah, I actually have it right here. Multiplicity. Root theorem slash multiplicity. Yeah, we just count the exponents of all of the factors. We have 3 factors. This factor has multiplicity of 1. This factor multiplicity of 2. This factor multiplicity of 2. So 2 plus 2 plus 1 is 5. Easy peasy. It's a freebie. Nobody should miss this one after today. All right. So we should have 5 solutions. Whether we have duplicates or not, we should have 5. All right. Question number 4. Um, what is the factored form of the polynomial? All right. So given this, by the way, how many factors should we get? Yeah, we should have 3 factors, and it's because, well, the highest term is a factor of 3. So we should have 3 factors when we're done. All right, how should we start this problem? Yeah, graph it. So we could do it the very long and probably horrible way of generating a PQ list and then testing every every number in the list that we found to see, if one or more work. The easier way is obviously to graph. So we are going to graph it, and I think for this one, if you graph this polynomial, I think you can actually see all 3 answers. But um, just to do it this way, I for sure one of the roots is x equals -4. So we're going to do synthetic division, well, with -4 to reduce the equation. So we drop the 1, -4 times 1 is -4, plus -3 is -7, times -4 is 28, minus 18 is 10, times -4 is -40, plus 40 is 0. So there's the synthetic division done very quickly. And then I can rewrite this. Remember, this is one less power than the start. So this is x squared minus 7x plus 10. And I could do it again, synthetic division, or I can see, hey, can I factor this? Hopefully we can factor it. If not, we could try, we could do complete the square. If you want to do it that way, we could, which actually, don't do it that way. That way wouldn't be good. We could quadratic formula. We could try to factor it. We could graph it again. Yeah, that's one of the ways that I can really think of right now, top of my head. But it does factor. Two numbers that add to -7 multiply to 10. Well, -2 and -5 do that. So there's the other two factors. What was the first factor? If x minus 2 and x minus 5 are two of the three factors, what's the first one? X plus 4 is correct. Yep. So there's the three factors. It is factored completely, and then those are the roots. And this is if you graph this, you would easily find -4, 2, and 5. And without doing any of this work, we can just go ahead and write the three factors. Your final, your test question, it may be just as easy as this. You maybe just to graph it and pull out all the factors right away. But remember, it is opposite. So remember, the factored form versus the solution form. Remember, these are always opposite because you set the factors equal to 0 and solve. Don't forget that. I hate for all of you to graph it and then you type in the factors without actually converting them back into factored form, and you miss everything. I would be sad for you. All right, that was number 4. So now the last one of the day that we'll be doing, Descartes' rule of sign. So describe the number of possible positive zeros and the number of possible negative zeros. All right, what we're going to do is, actually, you tell me. Do you remember how to do this problem? Yeah, the number of sign changes. Yep. So I like doing like kind of little humps and dash lines when we have same or different. So I don't know where I put my pen. No, I gotta look for my pen now. Use my finger. All right. So positive to negative, that's a change. Negative to a negative, that's the same. Negative to a positive, well, that's a change. And then positive to a negative, that's a change. All right. So how many changes do we get? Yeah, 3. So so the possible positive real is going to be 3. Just 3? Yeah, 3 or 1. There you go. Remember, it's always multiples of 2. So we start at 3 and then we keep going down increments of 2. So 3 or 1. So if we were to actually solve that for all of the zeros, we would either get 3 positive real solutions or 1 positive real solution. All right. So and then the negative. We have to do what? You better recall? Or when they actually went through this, know now? We have to make all the x's negative. Yeah, so we have to find f of negative x. So we're just going to replace all the x's with negative x. And don't forget, we're putting it in parentheses. It does matter. And then we have to simplify. So a negative number to an even power makes it what? Yep. Makes it positive. Good. All right. And then a negative number to an odd power makes it what? Negative. So this becomes negative, and what's a negative times a negative? Positive. Yep. All right, and then the next term, a negative number to an even power makes it positive, so it doesn't change. It still stays as a negative 7x. And then we have, positive times a negative is negative, and then your minus 1. All right. So we simplified that. And then we do the same thing. We count the sign changes. Positive to a positive is the same. Positive to a negative is a change. Negative to a negative is the same. Negative to a negative is the same. All right. So how many negative real roots are we going to find? Yep, just one. So that is Descartes' rule of sign. That was number 5, right? That was the 5th one of the day. 1, 2, 3, 4, 5. Yep. All right. We are going to stop here today. We'll be doing 5 questions a day, just to keep on pace. So your job today is to complete the next 5 questions, and then tomorrow we'll be going over those. Sound good? Slow and steady, right? Slow and steady. Don't forget, next week is your NWEA test. I already created the Class Connect session. I don't recall what day it was, but it does kind of interrupt. Or I think it's on Wednesday and Thursday next week. I think Wednesday is your math test, and then Thursday is your English test. And everyone in pre-calc must take that test, and then do your very best. So keep that in mind on your schedule. Next week, Wednesday and Thursday is the math. Or sorry, Wednesday is the math, Thursday is the English. You'll get through it. We don't have a whole lot to do other than prepare for your final from this point on. Hopefully everyone is all caught up on their units. Oh, by the way, if you did not notice, Raise My Grade, I have opened up every unit for everybody in this class. Everyone in the class has a second opportunity to retake units 1, 2, 3, or 4. Everybody, without even submitting anything. So if you want to retake one of those part 1s of those tests, it's open, ready to go. You just need to review properly before taking it. The password is the same as it was the first time, and you can find the password at the end of the review sessions. So if you didn't know that, well, there you go. Opportunity to get your grade up. By the way, that is not my choice. If it was up to me, I wouldn't open it, but it was a decision made by, well, pretty much the entire school administration and the math team. December 12th, I think, is the deadline, Noah. All right, everyone. Well, have a great rest of the day. Get some work done, and I will see all of you tomorrow. All right, take care.